Yes. Coming to the last topic, usually that we have in Engineering Mathematics 1 of calculus, that is alternating series. All of us know the basic definition of alternating series. Only thing is, how do I handle alternating series? Okay, what exactly is an alternating series? A series in which we have alternatingly positive and negative terms. There's a sequence. Okay, series means there's a sequence. Okay, I can just show. And then in this, the most important topic is absolute convergence and conditional convergence. Okay, alternating series is a series of positive and negative terms. See, I can have something like -1, 2, 3, -3, 4, and so on. This can be one type. Another type can be 2, 4, -6, -8 means alternatingly 2 plus 2 minus kind as well. Okay. Yes. Now the test that I have for alternating series is in the scope of our syllabus is Leibniz test. What exactly it says is if UN is a sequence of positive terms. See, in alternating series, these terms are connected. Series means they are connected with a positive sign. Yes. Okay. Now, even these terms would be connected with a positive, negative signs. Okay. Now, if I'm considering the elements of the sequence or the numbers of the sequence, the sign doesn't come. It's just the first term that would be 1, second term that would be 2, third term that would be 3, and not -3, like that. Now, if I have a sequence of positive terms where what Leibniz test says is, usually we apply Leibniz test for alternating series, that is clear. Now, what it says is if I have a series of positive terms where the positive terms are in the decreasing order. That means what? First term is greater than second, second is greater than third, third is greater than fourth, nth term is greater than or equal to n plus 1 term. That means what? It's a decreasing sequence. Then n tending to infinity, u1 would be 0. Okay. That's the condition for Leibniz test. Then you will say that the series is converging. That's what that's what Leibniz test says. What it says is, let me write here, summation -1 power n un, which is a series of alternating series. Okay, series of positive and negative terms. Summation, this series is convergent. That's what Leibniz test says. So the only test that we'll apply in the scope of the syllabus of Engineering Mathematics 1 would be our Leibniz test for alternating series. Okay. Apart from Leibniz test, the important topic, most important topic is checking for absolute convergence and conditional convergence. All of you are aware that absolute means what? Absolute means what? Taking modulus, right? All of you know that it's taking modulus. Now, when does this need? When I have all positive terms, I have something like 1, 2, 3, 4, and so on. If I have a series like this, I don't need to take the absolute value of this series. Why? Because all are positive. But then when I have a series of positive and negative terms, then I need to apply, or I can apply absolute. Absolute, I can take absolute value. Okay. So what absolute convergence definition says is, if I have a series, alternating series, actually, it is specifically an alternating series where I'll apply modulus for each term. Okay, if that mod of the series, if it is convergent, or if the absolute values of the series is convergent, then the series is said to be absolutely convergent. The word is absolutely convergent. And this absolute convergence and conditional convergence is valid only for alternating series. Now, what if the absolute value of the series, if I take the absolute value of the series, and what if it diverges? Then we will say that it is non-absolutely convergent or semi-convergent, or the proper word is conditional convergence. Conditional convergence. Mind you guys, here I have to make a note that where I take absolute value for the alternating series, I made a mention at the beginning of this video that there is only one test, that is Leibniz test. Okay. But then when I'm considering an absolute series, when I'm putting a modulus for each term, then all the positive series tests are valid for this absolute series. So I'll apply one of the absolute series tests like the ratio test, Rabi's test, or the Cauchy-Centruit, or comparison test, or other tests in my scope of the syllabus. Whatever tests I have, any of those tests I can apply and check for its convergence or divergence. Okay. Yeah. Coming to an example for checking absolute convergence. How does an example look like when I'm asked to find absolute convergence? Okay. Let me write down. The question would be test for absolute or conditional convergence of the series. Okay. The series is being given like this. That is 1 by 6 minus 1 by 6 into 1 by 3 plus 1 by 3 into 5 by 6 into 8 into 10 minus 1 into 3 into 5 into 7 by 6 into 8 into 10 into 12. As I have told you in my previous video, how will I check the nth term? I'll go with a plus 1, n minus 1 into d. Usually AP works. But then first and foremost thing that I have to write once I have seen a series of this format is, it is an alternating series is what I will write. It is an alternating series. First, I will write that. Okay. Now I'm asked to find whether the series is absolutely convergent or conditionally convergent. So for absolutely convergence, what I will do? First, I will write the nth term. Okay. Summation minus 1 power n un. First, I have to write that summation. I think I can take 1 by 6 common and then put the AP. Okay. So I'll be having what? I'll be having 1 by 6. Okay. And 3 into 5 into 7 and so on. A is 3, D is 2. So A plus n minus 1 into 2. Okay. So I'll be having what? 2n plus 3 in the numerator. Okay. Similarly, in the denominator, I have 8 into 10. A is 8. The difference is 2. So 8 plus n minus 1 into 2. So 2n minus 2 plus 8 is what I will have. So it would be what? 8 into 10 into 12 dot dot 2n plus 10 is what I will have. Okay. Fine. Huh? No, not 10. 2n plus 8 is what I will have. I'm sorry. 8 only, right? 8. What I will do here? A is 8, n minus 1 into 2. Okay. So I'll have 2n minus 2. Okay. It would be 2n plus 6, I think. Not 8. I think this is an error here. 2n plus 6. Okay. Yes. Now this is my nth terms. What I have to do, I have minus 1 power n also, guys, because it's an alternating series. I have minus 1 power n also. Now what I should do for checking absolute convergence, I'll be considering summation mod un. Okay, that would be what? Of course, 1 by 6 is there. At the end, I can multiply. Okay, yeah. So I'll be having what? Summation mod 3 into, of course, modulus I have taken. So minus 1 vanishes off. I need not take mod. I'll be having 3 into 5 into 7 and so on, 2n plus 3 by 8 into 10 into 12 and so on, 2n plus 6. This is my nth term. What would be my n plus 1 term? Since it's a positive series, I can go with ratio test. So I'll be considering un by un plus 1 ratio, guys. What would be that? 3 into 5 into 7 and so on, 2n plus 3 by 8 into 10 into 12 and so on, 2n plus 6. Okay, into denominator by denominator goes to numerator, as I have said in the previous video as well. Okay, 2n plus 6 into 2 into n plus 1, I will write. So 2n plus 2 plus 6 would be 2n plus 8. Right? Next, 3 into 5 into 7 and so on, 2n plus 3. In the place of n, I'll be putting n plus 1 for the n plus 1 term, 2 into 2n plus 2, which would be 2n plus 5. 3 plus 2 would be 5. Okay. So, as you know, all these things get cancelled off. I'll be left with un by un plus 1. As n tends to infinity, I'll consider without loss of generality or without losing. So I'll be having what? N into 2n plus 8 by n by n into 2n, I mean 2 plus 5 by n. Okay. So as n tends to infinity, first I'll cancel off this n's. Okay. Then as n tends to infinity, I'll be having 2 by 2. Since limit n tending to infinity, 1 by n would be 0 or 2 by n would be 0. Okay. So what has happened for the absolute series? D'Alembert's test failed. So I'll be going with Rabi's test. Okay. So I'll be I'll be writing here. Ratio test fails for L is equal to 1. Ratio test fails for, where is L that you should write, guys? This is 1. This is my L is what you should write. For L is equal to 1. So I'll be considering un by un plus 1 before applying n tending to infinity condition minus 1. Okay, so it looks something like this. That is, okay, that would be what? No, just a second. That would be what? 2n plus 8 by 2n plus 5 minus 1 would be what? 2n plus 8 minus 2n minus 5 by 2n plus 5. Okay, so 2n plus 2n and minus 2n gets cancelled off. 8 minus 5 would be 3. Okay, then I'll be multiplying with un by un plus 1. I need not make a mention of the rabies test here, as I have mentioned in the previous video as well. I just need to write things and then finally conclude. 8 minus 5 would be 3, 3n by 2n plus 5. Now, if I take out n, I'll be having 3 by 2 plus 5 by n, guys. And now I'll be applying the limit n tending to infinity. Limit n tending to infinity, n into un by un plus 1 minus 1. I'll be considering. So I'll be having what? 3 by 2. Its value is what? Something like 1.5. Now this value is L. L is greater than 1. L is greater than 1 or 1.5 is greater than 1. Hence by rabies test, the given series, hence by rabies test. Please be careful. Look at the series once again. Hence by rabies test, summation mod un is convergent. That means what? The series is absolutely convergent. The series is absolutely convergent. Yeah. I just want you to recall the definition of absolute convergence. It's very simple, very plain. What that is if I take the modulus of all the terms in the series, then and then apply when it is a modulus, then it would be a positive series, guys. As I have made a mention, it would be positive series. So when once it is a positive series, all the tests for positive series will be applied, can be applied. Okay, now I'll use any of the tests. As here I have used ratios and rabies, and I could conclude that it is convergent by using rabies. Okay, hence I should conclude properly and then as well underline what my conclusion is. Okay, I here test is not important. What I should write clearly is absolutely convergent. What is that? That is absolutely convergent. The given series, alternating series is absolutely convergent. That I will highlight not to lose marks. Okay. With this, I'll end this video for absolute convergence. If there's anything else, I'll try to do one more video.